Hello and welcome to another exciting episode of Innovation Coffee brought to you by ARM. My name is Robert Wolf and I am your host today. We are joined by Keenan Johnson, ARM Innovator and Entrepreneur, here to talk to us about a bunch of cool stuff he's working on. Now, I've admired Keenan from afar for a long time, and he's been an ARM Innovator inside of our group here for a long time as well. So I am personally very excited to get to know this awesome person and talk to him about this project and how he's addressing or applying technology to climate change. Now, first of all, as we usually do, a recap of last week's episode. However, as you may have heard, I was not feeling so well last week. I went on holiday and came back with a little bit of a stomach bug, but I'm all back 100% now. We're going to keep going with this show. I hopefully never miss another one. It's kind of been my thing, trying to make sure that I am always available for these streams. I think the only Thursday we take off usually is the Thursday of Thanksgiving, celebrated here in the United States. So if that's the case, then maybe this is the last one I ever take off, except for Thanksgiving. So anyways, we have some exciting things planned for you. So make sure you stick around. And what's that? We tried to nail it. This just in. Oh my goodness, some exciting news. ARM Dev Summit, you already know registrations are live. They've been live for some time now, but now the agenda is officially up there and ready for you to go build your schedule. So if you aren't already registered for ARM Dev Summit, go to devsummit.arm.com right there, register for the event, and you can now build out your schedule, everything from keynotes to sessions to workshops. And from what I understand also, workshops, they're going to be open to anyone. So you can go in there. I don't think that there's a cost for any of these or most of these. There's just so many cool things you can do. We're opening a community chat forum. You can join us on our new ARM Discord server, and we'll share that link as well. So don't miss out on that. Now, another really cool development, of course, you may have heard about the ARM competition, which is running in parallel leading up to the ARM Dev Summit as well. So ARM competition right here again, developer.arm.com/Dev Summit-competition. Lots of prizes and lots of opportunities there to collaborate with your fellow engineers, software developers, as well as us from ARM. So don't miss out on that opportunity. Now, I think it's time to meet our guest. So let's bring in Keenan Johnson. Welcome to Innovation Coffee, Keenan.
Hello. Hi, everyone. Hey,
Cheers,
Robert.
my friend.
Cheers. I've got my coffee here. So good morning. It's so good to see you.
You put cream and sugar or just black?
No, I'm a purist. I'm all black coffee. I went to Costa Rica once and the coffee is incredible. And I just got addicted to just black coffee because it's the best.
I try to drink black coffee. Usually what happens is I pull out my coffee. I grind my beans every morning, so it's like super fresh. And then I put some vanilla creamer in, and then by the second cup, I don't put any more in. So the second cup becomes more black. There's still a little bit on the bottom, so I think the second cup is actually my favorite because the first one I never can determine how sweet I make it. So
that makes sense.
Cool. Well, Keenan, welcome to the show. Welcome to Innovation Coffee. You've seen the show before. What we usually do at the beginning here is what we call the origin stories. So we want everyone to get to know you, who you are. Could you just kind of tell us a little bit about who Keenan Johnson is and what you've done?
Of course. Yeah. So my name's Keenan. I'm coming to you from Seattle, Washington, here in the United States. I've lived my whole life in the States. I grew up in the middle of the country called Missouri, which if you're out of the US, you've probably never heard of. But yeah, I'm an engineer and maker kind of person. I've spent my life and career in technology. I think I always wanted to be an engineer. Like I really love the craft and like practice of creation. And engineering is just this cool job where you just get to do that as your job. Like you just get to spend all day creating, which I think is great. You get to look at problems that you see in the world, try to fix them. I've done a bunch of things. I sort of started off, I went to school, got an electrical and software degree called computer engineering. So it's like half electrical engineering, half software. I got to do a lot of cool projects in space in university, and I really wanted to go work in space because that was some of the coolest technology I could think of. I think it's also some of the most aspirational technology. So that's been a really like important thing that I've really loved, is just thinking about aspiration and hope in society. And, if you think about space, it's sort of the most aspirational place you can go. And that's where I was really attracted to it. And so I went and worked at SpaceX for quite a long time. They were building reusable rockets. When I started there, we had basically one rocket that we built a year, and we flew once. And when I left, we were flying a couple times a month, and we had just reused our first rocket, which was an incredible feat that like no one thought was really possible in aerospace. And that was just such an awesome experience. I got to work on this really small team called just launch and test as the team. And we did everything after the production line of the rockets. So we would build up the test sites. We would do a bunch of tests in Texas. We would go out to the launch sites and launch rockets. And a lot of my job was writing software. So if you think about like the mission control that you see on TV, there's people sitting around like looking at computer screens. That's the software that I was writing, everything from that software on that display down to like software that is on the back end that's like opening and closing a valve on a launch pad, which was super cool. So I had kind of done that. I did reusable rockets, and I really wanted to work now on problems that I cared a lot about. And one of the problems that has been super compelling and interesting to me, because I think it's one of the greatest challenges and opportunities that we face as society, is climate change. And I really wanted to go work on that. I had no clue how I was going to work on climate change because I didn't know anything about it. I only knew about aerospace engineering. And so there's an analogy, or like a story people tell, a little anecdote in startups called, a startup is like you jump off of a cliff and you try to build an airplane on the way down. And that was sort of the theory of what we did exactly in our startup, because we were like, okay, airplanes, we should have electric aircraft. Like that would be great. It's sort of, a niche area that like me and my friends' aerospace skills could really help out in. So we tried to build this company that was creating electric aircraft in an all new way. And we did that. And, that's sort of my intro into startup climate change land. And we built, a kind of small, awesome, like MVP aircraft, which is a small drone, could fly for 2 hours, which is way longer than any drones at the time, which could fly for like 20 or 30 minutes. Super cool electronics engineering project. We were also building a company at the same time, which is cool. And I've sort of been in the startup climate world ever since, always working on technology. I've worked in a bunch of other cool projects. Like, kind of at the beginning of 2020, I was working on an awesome autonomous submarine project. Most recently, I've sort of moved, I guess, up in the stack of the startup ecosystem. And so I was actually on staff at a startup Accelerator, which helps climate tech startups all over the world succeed, because it's really hard, like working on climate and startups. And yeah, now I'm sort of back in the entrepreneurial world working on a project that I think is really exciting. But that's, I guess, my story. I don't know.
And we're going to talk about that project too,
cool.
in a little bit. Yeah. So Keenan, I want to like kind of touch on some of this stuff. Like, I'm born in the 80s, right? And so I was raised on some of these cartoons that were, pushed out in the late 80s, 90s. And there's this one that came out called Outlaw Star. I don't know if you heard of it.
I don't know it. No.
It's worth checking out, I'll tell you, because when you say, oh, this rocket went up into the air and then it landed on its own, right? Like, this is what they were showing in these animes that I was watching. And
Cool.
I think like, wow, that's just amazing. And I remember when the videos came out of that first rocket landing on its own, standing up, landing. And, the average person looks at that and is like, cool, right? But in reality, it is such a huge feat that humanity has reached a point where we can send a rocket into the air or into the borders of space and then have it land standing up. And when I watch some of the reactions of some of my friends, and I'm just like, how are you not just like baffled and thoroughly impressed at this achievement? And so, being raised on those types of cartoons, watching that and waiting for one day, we're able to reuse all of this materials that we used to just throw away.
Yeah.
That's crazy. You worked on that. That's amazing.
Mhm. Yeah,
That's
it was
so cool.
so fun. And I think, it's science fiction like level stuff. Like this is stuff that you only read about or watch in animes. And it really showed me that like, oh yeah, like we can, like society, humans can do amazing, like impossible things if we just decide that like, yeah, we're gonna do this. Like we're gonna work really hard, but like we can do it. And that was so eye-opening as an experience to me. That's like been really formative for me to how I think about the world.
I love that. And, it is something that I think is necessary when it comes to innovation, right? People will always say that can't happen. It's too expensive. The thing I think that innovators, people who innovate, they look at it from a different lens. They say, oh, well, you say it's too expensive. Well, then let's find a way to do it differently. And that's innovation. That's when we as humans really kind of push the threshold of what we're capable of doing, is when that one person comes and really thinks out of the box and says, we're going to do this differently now. So same thing with your drones. I mean, when I was watching you talk about this at Arm TechCon, I think it was like 2018 or 19, you're thinking like, okay, well, drones or RC cars, you put this little battery pack and you're just like, no. We're going to reinvent this wheel. We're going to just build our drone out of batteries. The batteries are going to be the scaffolding of the drone, if that's the right word to use. And so I'm just like, wow, that's amazing. How has no one thought of this yet? And here comes Keenan and his team thinking about it and building it. So that's so cool.
Yeah, I think thanks so much for the kind words. I feel so fortunate to have been, I've had so many great experiences that have been so lucky. And like, I feel so fortunate, but yeah, I've really been able to like have a lot of optimism and like say like, yeah, like why can't we make airplanes or drones fly longer? Like, and try to not let yourself be constrained by like, oh, well, it's hard, or like this is the way that it is done. Like really try to think about like, okay, well, like what if it wasn't? And so like the drones were a great example of that. Of like, if you look at all drones that exist or all airplanes, it's like, okay, there's like this small little battery in here, and it's like, oh, okay, well, I don't know how to invent a new battery. Like that seems really hard, but like I can put more batteries into the thing than
so
anyone
much unused
else.
space, right? Like so much unused space that can be
Yeah,
utilized.
like so. I mean, and that's hard, but like, okay, like that seems doable. Like we can work on that. Like that's a problem that we can iterate on and solve. That doesn't require like some like chemistry like breakthrough that's like really difficult. It's like
new element.
Yeah, like looking in your tool bag of skill sets and say like, okay, like how can I use like my small amount of skills that I have to like solve this problem? And like I feel like almost always you can figure out a solution. It might not be the best, but it's probably like better than some other solution that's been before if you like really put in the work to do it. And like I hope that people realize that like true innovation is not, it's like thinking about problems and then like pursuing them. Like it's not really about like having some miraculous breakthrough that no one else had. Like
sometimes it's the simplest change that makes all the difference. So yeah, I mean, and you've done quite a few of these, which is awesome. So as I mentioned when we were opening the episode up, like I've admired you from afar. I really have. You've been an ARM innovator for a long time. I've watched a lot of your talks, and I've looked at your website and stuff you've been doing. And so I have noticed, both from you telling us in your speakerships as well as on your website, you've just done so many cool things. We've already talked about the rockets. We've already talked about the drones. But I mean, you've done zero-G experiments. I mean, I want to hear about this. And also, like, think about it. How many people have gone in a zero-G airplane to experience that? It's like a dream. So could you tell us a little bit about like that experience? Like, what were you experimenting on? How was that feeling?
It was a dream, and it was one of the coolest things that I got to do during my time at university. And it's actually miraculous in hindsight that like this existed. And so here in the United States, NASA used to have a program where like student teams could like pitch experiments they wanted to run in zero gravity. And if you got selected, they would take you down to Houston, Texas, and you would fly in this aircraft they call it the Vomit Comet. And what it does is it does these parabolas, and essentially like how you can get zero gravity is the pilots just put the plane into a nosedive down.
Wow.
So imagine it's a 727 sized aircraft that is just in free fall, which is crazy. And then you just do that in a bunch of loops. And they just like let you take your experiments on, and you get to float around in zero gravity, which is so fun. Like it's the best.
On your way up, are you experiencing more G?
Two gravities.
2G.
Yeah.
Okay. So they're going up faster than a regular airplane. Like if you take a commercial airliner.
Oh, for sure. It's like you're pinned on the floor. Like it's 2 gravities. The 2 gravity part is a little bit uncomfortable for sure.
And did you experience any of the Vomit Comet?
I did not, luckily. Yeah, most people don't. So most of the flights that they do, they said like actually nobody is sick. It's just like occasionally, and it's usually if somebody, if you're gonna get sick, it's in the 2 gravity part. And it's usually because you try to get up and like do something. And like that's bad news.
Like when you're on that graviton thing at the fair.
Yeah, where you like stick on the wall at the fair. That's exactly how it feels like. And yeah, it was super cool. Like, so I got to do that. I did it, as soon as I found out that was like a thing that I could do at school, I was like, yeah, like I will do that. Like, I don't know. I had no reason. I was just like, that was actually how I got into space. Is just like, whoa, like I can join this team and like maybe I can go be in zero gravity. Like, heck yeah, I would do that. And it was awesome. Like I flew 4 times, I think, in my university experience, which is awesome. And we did a bunch of different experiments. We did 3 that I was really a part of. One was welding in zero gravity. So if you think about welding, it doesn't really like work the same way in zero gravity as in gravity. Like I'm not a welding expert, but like the way that the molten metal flows is just super different in zero gravity than in gravity. And so like that's like an unsolved question of like, oh yeah, how is that going to work if we're going to like go build stuff in space? Like we'll probably need to weld, and we don't really know what that means. So we built this like robotics thing. Like the best experiments also were the ones that were robotic, because you could just hit a button and then play around in zero gravity while the experiment ran, which is like the real fun bit. So we did that one. We did another one where, a lot of schools have a small satellite team. And so we were testing like the propulsion system of the satellite, which is really hard to do in gravity. And so we like put like their fuel tank and like a tiny little thruster on an air bearing, which is like a zero friction like mechanism. So you can fire the thruster as if you're in actual space and like see if it's performing correctly. And then the last one, which we did, which I thought was super cool, which was like the least automated thing that we did, was CPR. So so cardiopulmonary resuscitation. So like, on Earth today, one of the basic techniques of first aid is like, if you're having a heart attack, somebody will come and like perform CPR on you to like keep your heart going or possibly restart it. And it's kind of like a basic CPR thing that doesn't work at all in zero gravity, because
you just push yourself away.
Would just push the 2 of you away if you think about it in sci-fi. And so there's no answer to this. Like the NASA procedure at the time was like, okay, well, if somebody on the space station, for example, had a heart attack, pretty unlikely because they're like super fit, but like, it could happen. They would like, find there's like an area in the space station that has Velcro, and they would like Velcro strap that person down. And then like somebody else would have to Velcro strap themselves down and start CPR. And that takes a long time. And for CPR, it's like seconds matter for like your health. And so we were trying to develop this really cool way of like, you get behind the person and you use this like suction cup device to like do this kind of motion where you're like, you're not resisting their force, and you can do CPR very quickly in zero gravity. Which was super cool research, and I think really valid. Like I think that we were the only people who've ever done anything like that, which I thought I was super proud of it.
Yeah, no, that's awesome. Yeah, I mean, it kind of reminds me a little bit of the Heimlich, right? But you're
Yeah, it's
probably
very
addressing a
similar.
different area, right? The
Uh,
Heimlich's down, I think, by
yeah,
your diaphragm area,
totally.
your heart's up here. But yeah, I mean, I heard that during CPR, in a lot of cases, it's not so uncommon. The camera's going out of focus here. It's not so uncommon for, it's off topic, but like for people's rib cages to collapse, like because you have to put a lot of pressure on there. And so,
Yeah,
that
it's
being
hard
said,
work.
yeah, it's hard work. Cool. So Keenan, we're at about the halfway marker here. We've talked so much about all the cool things you've done. I think it's time to now hit the present, right? So let's go into the present. I want to talk about, and this is, we're still actually a little bit in the past here because you just recently left your most recent job, and this was with a company called Third Derivative. So before we dive in, I think this is maybe where your whole project maybe stemmed from. I'm not sure. But could you tell us a little bit about Third Derivative and what they did?
Totally.
Or do?
Yeah. So like I said, I've been able to work on climate change kind of stuff forever. And I've gotten a chance to work with so many awesome startups. And I was like, yeah, I want to do more of that. Like I want to work with as many startups as possible because like we need everybody like working on climate change that wants to. Like there's not a limit of problems here. And so I got the opportunity to work at a climate tech accelerator that was just starting up. So it was like a startup to help startups. Accelerators are programs that basically, they help startups accelerate. They help them grow fast. Having a business of any kind is super hard. Having a high technology business, even harder. If you're having a business in climate, you probably have all these policy questions and like there's government relations, and that's even harder. And so there's this awesome nonprofit think tank that's called Rocky Mountain Institute. They've just rebranded, so they're called RMI, is what people call them. And they've been around since like the 80s, just kind of doing like think tank work, which is super cool. They like write white papers and publish those, and like that's grand. And they were like, actually, we're going to be a think do tank now, and we're going to like do more direct things. And one of those things was starting this accelerator. So the first cohort of startups, which I came in as we called it startup success manager, but I was basically a startup advisor. So I chatted with these startups all day, every day, and we had 50 of them almost from all over the world who were working on all kinds of technology climate problems. So we had software companies who are working on like finance kind of solutions for like, how do you finance climate projects is like hard. It's like very old school how to do it, all the way to like, there was a company in Indonesia that I got to work with that worked on a leather replacement that is grown from mushrooms, which is like way more climate friendly than like a traditional leather.
This is real life or Minecraft?
It's real life. It's super cool. We had like, solar panel companies. We had some really interesting like innovative technologies related to like batteries. So recycling batteries. We had one company that I was a big fan of that they do a CO2 battery. So they compress, gaseous carbon dioxide to store that as the battery instead of having lithium batteries. And then they decompress it. So imagine they'd like fill a big balloon. And so it's at pressure and they decompress it. It spins a turbine, which is a little generator. And that's how they generate electricity, it's super safe. Stays like if it doesn't leak, it won't discharge.
So I have a question for things like that. I mean, at least like the physicist in me wants to know about how much energy it took to compress it to begin with. Because if you're taking energy to create a source of energy, then your source of it, I mean, entropy is always there, right? Like you're always losing energy at some point. Chaos is on its way. And
totally.
So what the same thing comes to my mind when you think about solar panels, right? Like, okay, I get a solar panel installed on my roof. It's not just like the solar panel is going to last 20 years before it's at 80% efficiency. It was created somewhere in the world. There was emissions. Then it was put on a truck to a boat. There were emissions. Then it was shipped across the ocean. There were emissions to another truck, to a warehouse, to another truck, to my house. And so like, there's emissions all the way. Am I going to actually make up for the emissions that I put out there in the process?
Yeah, totally.
Those 20 years.
Yeah. both are great questions. So like, let me talk to the first one first. So you're right. Like it takes energy to compress that CO2. One of the cool things about the way the electrical grid works is it's not like a static thing. So most of our big power generation plants kind of are like outputting like a fixed amount of power. And usually if you look at like an electrical grid, there's like times where there's a lot of use and a lot of power consumption, and there's times where there's less use, maybe less power like production. So what your electrical company does is they try to say like, okay, we know between like 2 a.m. and 6 a.m. we're producing more power than people are actually using. And in a lot of cases, like if you imagine a solar farm or like a nuclear power plant, it's producing the same amount of power no matter what, like if people are using it or not, and they can either like burn that off as heat or store it. And so a lot of times storing it is free, and then they want to save that up to use it when there's more demand. For example, like during the day, there might be more demand than they can handle, or like maybe it gets really hot randomly and everybody turns on their air conditioning, so there's a lot of power. So the storage aspect, is not free, but it's really important for like shaving. They call it peak shaving. Is like the utility term.
Okay. Wow. I never thought about that. That's interesting.
Yeah. And so because a lot of times what happens, the utility companies are fascinating. They have like different tiers of power plants. They have like a base load power plant, which is like generating all the time. It's like a fixed amount. And then they have like a second tier, which is like peak power plants, which they can turn on and off really quickly. And they would love it if that was just like a battery, you could just like switch to it and it's like boom, like whether it's lithium ion or compressed CO2 or like water pumping or like whatever it is. Unfortunately today, a lot of those power plants are like, they burn natural gas or coal, which is not great. And so they turn those on in the peak, and that's where a lot of the emissions from the utility grid come from. And so like any technologies that can like get rid of that, super good for climate change.
Very nice. Very nice. Yeah. Okay,
and then,
cool.
Yeah, I think.
Sorry, please.
To your second question about like, there are emissions for things. It's a tough problem to think about, and like every action that you do has some impact on the world. Like if me breathing here is like generating some change in the world. And I think it's okay. Like I think you're gonna have impact in the world, and the thing to think about is just like, if I'm doing a thing, like what's the net benefit? Like does me having the solar panel like ultimately save more carbon than like its production? And that's what a lot of the people who work in climate change, a lot of the engineers and analysts, spend a lot of time trying to think about the answer to that question. And for the most part, the answer is yes.
You really need to study the supply chain, right? I mean, like, sorry, I didn't mean to interrupt you.
No, yeah. You have to study the supply chain. It gets really complicated because like you have to think about not only your supply chain, but like, all of your suppliers' supply chains. Like, for example, like, I don't know what I have, but like this inflatable arm guy, like, if I was building this, like I would have to buy maybe this fabric and like the plastic, and there's like some electronics in here and like some batteries. And like, I have to go study the fabric companies like supply chain to figure out like where their carbon emissions are. And it's a whole field that's kind of new-ish. Like people are still trying to figure out how exactly to do it. And there's a lot of different ways, but it's super important like to understand, and it's really cool work, I think.
Yeah, I think that's going to be like some of the careers of the future. I know it, like with the whole, this should have been a thing a long time ago, but here we are now, and there's no going into the past. So hopefully this becomes, careers of the future. It's who knows what kind of titles they'll have, but I think that's really interesting to look at.
And I think like if you're going to school right now and you're getting like an environmental engineering degree, a lot of those people end up having jobs that do really important kind of analysis like that, I think, is probably what they'll end up doing, which is super cool. It's also cool because there's a lot of technology being applied there. So like doing that analysis every time from the ground, like by hand, is super tedious and kind of silly. And so like technology has a big role to play there. And like, how do we use software to help answer those questions quickly?
I mean, I remember when I was in university, I was in a class called Global Ties, and it stands for Teams in Engineering Services. And so, like, we had these projects that we would build. One was like this self-sustainable solar-powered shipping container that we would send off to Fiji, and like students would have a place to go to computers and stuff like that, right?
Yeah.
But they put an environmental engineer in everyone's team, right? Because it's important to know the environmental impact of all of the things that are happening. And this is where, like, those questions popped up about whether or not buying a solar panel and having it installed is truly a sustainable act. And, it really depends on where you buy that solar panel from, where it was manufactured. And so, chasing it all the way back. But so, Keenan, I could talk to you for hours on this alone. Maybe next time we're at an event, if you drink beer, we'll go talk about this and have a beer.
Yeah.
But we need to talk about your project here, because we're on the border here talking about it. So I think it's called Rivet Network, right?
Uh-huh.
Okay.
Yes.
So let's talk about Rivet Network right here. We put the website up, rivetnetwork.org. What is Rivet Network?
Yeah, so Rivet Network is a project that I've just started, and I'm super excited about it because I think that it's one of the most important things that we can do for climate change right now. Kind of the situation with climate change is that we know exactly what's causing climate change. We're producing greenhouse gases at an incredible rate, like at a rate higher than ever before, and we've been doing it for a long time, and that causes global warming. And all kinds of other effects for climate change, which are super important. And, me being a scientist and technologist, like my first instinct is like, okay, like let's measure, let's measure how much emissions are coming out, where they're coming from, so that we can go like work on it. If you're like designing like a circuit or like a product, you would do that for power. Like, it's like, okay, how much power are we consuming for things? Like, we want to save power in our device. So like, let's figure out how much each piece uses and like figure out how to fix it. And we're in this crazy situation with climate right now where we don't have sensors that are widely deployed to measure greenhouse gases. It's kind of surprising to me. And it's been one of the things that, like, as I've been on my climate learning journey as a technologist, I've been very surprised, like, to learn that, because I always thought that, like, okay, yes, we know this is a really big problem. Of course, there are sensors everywhere. Not true. Like, there are very few sensors in the United States here. For example, there's only like 3 or 4 official climate monitoring stations that are operated by the government for the most part. And that's great. It tells us, like, globally we have a problem, but we need to understand, like, where do we have a problem? Like, because, there's different parts of New York City, for example, which produce way more emissions than like a rural part of America. And like the laws and policies that we change and like the way that we think about technology should be rooted in data. And so the Rivet Network is this awesome project to go build that sensing network so we can have this global map of like where emissions are, which I think is super important for thinking about our planet going forward.
This one thing comes to mind, right? Like, you just mentioned these CO2 or carbon emission tracking entities, right? And you mentioned that they're also controlled by the government. Now, for those who know me, I'm a huge fan of decentralization, cryptocurrency. And so to me, that is one of the most trusted networks available. So, if you're talking about, and this might not be, I'm not saying, oh yeah, Rivet is watching, sure, right? But like, if you are creating the ability for the average developer or entity to grab devices and then throw them on a network so that data can be collected in a decentralized fashion and supplied to a data set, I think that's pretty amazing. And so now you don't have to just, and I'm not saying like don't trust your government or don't trust companies, but like what I am saying is that people are, the power of people is amazing, and the power of a large amount of people is amazing. And so when you put this power into the hands of us, then we can really utilize it to I think our benefit. And so this is awesome.
You're totally right, and I think there's so many people who are feeling frustrated, like afraid, like not sure what to do. Like if you turn on the news, it's like super doom and
So
gloomy
negative,
about
doom and
climate
gloom all
change.
the time. Yeah.
And like that's not helpful. Like maybe they're right, but like who cares? Because like that's not a motivating like emotional state for humans. It's like, let's do something about it. And like having the ability to put a sensor and take agency over our planet that you are a citizen of, like by being here, is super powerful. And yeah, I think like having it be a decentralized project is super key, because this should be transparent and accessible to everybody on the planet, because this is a planetary problem that we all have to deal with.
So I want to read this. I want to read this off of your Rivet Network website, because I think this summarizes it pretty well. It says, the greenhouse gas sensor cloud, the Rivet Network, is a large network of open source, that's key, low cost CO2, hopefully additional gas in the future, detection sensors. These sensors will upload their data to the cloud, creating the world's most complete greenhouse gas data set built by citizens, scientists everywhere. That's a great paragraph. And then you even go on to compare it. And everyone knows this whole folding at home phenomenon that happened last year. And so you compare it. Imagine Purple Air, which I'm not familiar with, but folding at home. Purple Air and folding at home combined with an open source solution for climate. That's pretty amazing. Keenan, did you write that?
I did write that. Yeah.
Oh, that's awesome.
That's a few iterations, in the future. Like it took me a while to get to that, like really refine the pitch.
So I mean, this right here, I mean, you're trusting a decentralized network of people that are all in it for the cause. And I think that's really cool. So what can we expect from this? It says on your website, I'm looking at it here. It says join the wait list. And again, Rivet Network, I'll post it in the chat here so y'all can go there. But Rivet Network says join the wait list. So it's not yet available.
Correct.
Can join the wait list.
Yeah. So kind of my vision, I think the open source aspect is really important. Like, because for this data to be trusted, we need to understand how it was collected. And so that means the hardware, the software, everything has to be open source. And so we're committed to doing that forever. So all the hardware design software is all on GitHub. I hope because it's open source, one of the cool things is like you can build it. Like you can go buy all the parts if you want and build it. Recognizing that is not something that everyone wants to do. Like my mom, for example, has no interest in doing this. But she really wants to help out and just wants to kind of like buy the sensor. So we plan on like having these available, probably as like, both a kit, if you just want to like buy all the stuff from us and like build it yourself instead of buying it from, all the distributors yourself, or like a fully assembled one if you want. So you can just like pop it outside your house and go. And yeah, so right now, kind of what we're doing is we're very close to like the design of that first sensor being done. So like I have one here at my desk, for example. So like we've been working a lot on like the enclosure. So this is like what it looks like on the outside. It's like this little cute frog. It's this like fun face. This thing is called a Stevenson screen. And so it's kind of hard to see, but like there's tiny gaps in between each of these layers. And that allows air to, very easily flow through while preventing, rain and snow and also solar radiation from getting into the sensor. And then all the electronics are on this little card. Oh, let me put it in front of the camera. And this thing just super easily like slides into the sensor. Oh, that came apart and clicks in there. And then you can just hang this thing outside your house. It sits out there, monitors CO2 all day, every day, uploads it to our database.
Like a hummingbird feeder.
Mm-hmm. Yeah, it's just like that. And so it's pretty straightforward, I think, in terms of electronics. So we've got like a Raspberry Pi compute module 4 here this is a WaveShare carrier board, which is just like one of the smaller carrier boards for those tech folks. And then on the other side, we have the sensors. So we've got a GPS sensor, which is super important just to accurately tell us like where is the sensor in the world. We have the actual CO2 sensor here, which is super cool. It uses a technology called near infrared detection. So it's a tiny infrared light emitter that emits an amount of light. It passes through a gas, goes through this diffraction screen. And by looking at the way the light diffracts the screen with like a little image sensor, you can say like, okay, what is the concentration of CO2 in this volume of gas? Which is super crazy that you can buy this tiny laser thing for like $60. That's awesome. And then a barometer, which is super important for calibrating that CO2 sensor correctly.
So I'm thinking about this, right? I'm talking about batteries and storing energy. How is this going to be powered? You're going to have some access to power, or
Yes.
is it low enough?
Yeah.
So you do need to plug it in.
Yeah. So right now you need to plug it in. One of the like awesome things that I would love for this to be a super low power solar device. And so like in my mind, this is version like 1 of the sensor, and I hope that there are 1,000 versions of this that come after that are they get smaller, they get solar powered, they get like waterproof. Like I want to put these things on and in everything if possible. And that's like one of the cool things about open source is like you can go like help do that if you want, or like it's totally available to like get integrated into other products, like would be super easy, or like get reconfigured into different form factors. But yeah, I think like the very next thing would be like a solar powered, like lower power device.
And you know what? I think this is the perfect segue into my next question, because there are people on here. I mean, we already got a comment from Mark saying GitHub page for Rivet is a great resource for more info. Love it. That's awesome. I'm curious now, how might someone go contribute to this project? Because you say it's open source, and one of the beauties of open source is, that you all can build this together. And in fact, maybe someone even forks it and comes up with some other use case, right? But
totally.
That being said, Keenan, how can someone go and contribute to this and help you reach that dream of the 1,000 iterations, or maybe it just becomes perfect after 5? But
yeah. So like I said, it's totally open source, and I think I'm bought in on the open source like ethos. Like I have seen it do amazing things, and I hope that it will continue to do more and more amazing things like this. So yeah, we're on GitHub. That's kind of the primary like hub for everything. The documentation I think is pretty good. Like hopefully it's getting better and better every day. So there's 2 repositories on there. Maybe I can I guess share my screen and just like
let's
show you this.
Posting it also in the chat. So we shared it right there on the screen, but I also posted the GitHub in chat. All right.
Okay.
Your screen in.
Here's my screen.
Our executive producer behind the scenes, the wizard behind the curtain there, Rachel. Thank you.
Yeah. So this is the Rivet network. It's on GitHub. There's 2 repositories right now. There's the frog sensor, which is this. And I guess I didn't even mention this, but we're calling each sensor the frog since they join the Rivet network. That name is just kind of like I think it's fun is like really important, like to keep this fun and upbeat. But also frogs are cool in that one, they form like a really awesome collective network through their rivets. So they rivet to each other and tell each other so much information about the state of the world and what's going on, which is exactly what the Rivet network does. And then the second reason is frogs are actually some of the species that are most affected by climate change. So they're just kind of a good mascot for like this project that I think is like universally cute and appealing and fun. So we've got one repository that's the frog sensor. This has everything about like the sensor hardware, the software hardware. We're using, like I said, a Raspberry Pi right now that's connected to Wi-Fi. We use Belina, which is an awesome like IoT device management thing, which is also open source, and like big shout out to that project. It's great. So they just released a new feature, which is called Belina Fleets, which is like perfect for like this project, for like everybody to like download it and like plug their own device into this awesome crowd network of sensors. So that's all here. You can see like there's hardware, there's software, there's documentation. It's getting better. We're trying to track all of the work that we do in the issues, and you can already see there's some so awesome like community works. Like one of the things that we would really like to do is fully 3D print the whole enclosure, which makes it really accessible for people everywhere. And so like I had started, like this is an enclosure that I buy, and I just painted it, and I was like, okay, yeah, we should 3D print this. And then my friend Eric, who's an awesome mechanical engineer, was like, yeah, like let me jump in on this and like help out. And you can kind of see the whole design process as we're going of like designing a better 3D printed enclosure. And it's really cool because like this is transparent, like engineering stuff. There's like sticky note sketches in here. There's like CAD software, and you can really see how this design is progressing. And it's awesome. Like I'm so happy in the progress that we're making.
I have a friend that does a lot of 3D printing. Well, I should say does a lot of 3D design work.
Yeah.
If you're ever looking for additional help, I can point him over to this. It looks like obviously you have a very professional person doing this as well. But if you're ever shorthanded or your colleague there is shorthanded, he's looking for projects to contribute to.
Thanks so much. Yeah, I'll definitely you should definitely take a look at it. I mean, I think there's one of the like this project is so big and aspirational because like I want this thing, I want every house in the world to have this like as like a dream goal. And so like there is so much work between now and doing that. And like,
so let me ask you, I hope this isn't a gotcha question. I don't try these intentionally.
Sure.
But if you had every house in the world running one of these, then there would be a toll taken, right? You don't necessarily need my house and my neighbor running it per se, because we're kind of collecting the same information. That would be a little redundant and just consume more energy, right?
Mm-hmm. Yeah, and that's I think there's a few parts to that question. One is like I really want this thing to be off the grid. It's like it be a solar powered, like super low powered device is key, so that it is as self-sufficient as possible. One of the things that we're working on in the engineering is like how can we make this as recyclable and made of recycled materials as possible so that we consume as little as possible to like build this sensor. The other thing is that like I really do think in the long run, like, I say every house in America, and in the world, like in some ways that's an exaggeration, but in some ways it's not, because a lot of the academic papers that I've read, there's a big difference actually, like block to block of like what does the air quality look like. For example, like, if you live on a busy street but your neighbor doesn't, there might be a big difference. And I think, it's still an unsolved question of like how dense is dense enough? Like where do you get diminishing returns where like the cost to produce these things outweighs like the benefits? And like that's an open science question, which I'm super excited to go figure out. And I hope that and I'm sure that we'll know the answer to that by the time we get to that extreme of like, oh yeah, like it's feasible to do this.
You definitely bring up a good point though. I mean, like, for example, my house is up on a hill, but pressed up against the hill off of a main street. Then there's a house about 4 townhomes down that's on a main street on the top of a hill. And then if you go to the bottom of a hill, there's houses down there on another main street. And so literally we're kind of neighbors. And so, but our air quality could be extremely different. And so I can definitely see that. So
totally. The other thing, like, because it's a decentralized citizen scientist project, hardware breaks in the world. Like maybe like, I don't know, like hail comes, destroys one of the sensors in a way that like subtly breaks the sensor. It doesn't like completely stop working, but it like kind of stops working. And like, that's the worst case scenario in engineering. In my aerospace background, that's something we know how to deal with. And the way that you deal with that is you have redundancy in sensors. It's like having more than one sensor in an area is actually super good, because then we can take our awesome software tools and use machine learning and like all these data analytics tools that we've developed as an industry and say like, let's use that to like discard bad sensor data.
Build some consensus around the data that's actually usable.
Yeah. And so I actually think that it will be hard to oversaturate, but like we'll see. It's all super open science questions, and I've been able to work with a few university professors. Like this sensing idea of like surrounding a city with sensors comes from universities. Like there's one in Berkeley where they've done this, and they did the same thing in Munich. And like the science is pretty clear that like they think there's value here. Like this is proven. And so to me, it's like, yes, cool. This is an engineering problem. Like, let's do it. Because academia, they kind of stop at like publishing papers. And then it's the job of industry and like engineering to go deploy that out in the world. And that is awesome. Like, that's exactly what I know how to do and love. And I'm so excited to do it.
It's really cool. I have to say, Keenan, I mean, seeing your design, like as soon as you pulled up that device, the model you have made, I was like, yeah, I mean, I hang 2 vine plants on my patio and a hummingbird feeder. I would actually love seeing one of those hanging on my patio. Like I would look out there, I'd be like, wow, that's a really cool looking thing. And it's helping the environment. And so, or helping contribute to help the environment. And so I think that's just awesome. And so, I mean, I hope that this takes off. I hope that, I can get one of these. I don't know if I'll be the person that 3D prints it and builds it myself.
Yeah. And it's not for everyone.
Yeah. But I would definitely love, cruising over to Costco and buying one.
Yeah, totally.
Let's get it in Costco.
The building it is not for everyone, but I think it's important like that if it is for you, like you can do that. And I think the educational aspects of this could be like infinitely great.
Get them in classrooms everywhere. You got the Raspberry Pi in there. You got
for sure
a great repository. This is something that I can definitely see growing some legs. No pun intended. Legs, right?
There you go. Yeah, and so it all goes into this database. It's all linked on the site. You can imagine like, let's cover this globe with sensors that you can click on and like see all the data and get that to the scientists. That's kind of the vision for Ribbit Network.
Yeah, and that I'm guessing this is a live sensor from Seattle.
Yeah, this is from my house, which is like the one where it exists. And so this is like the last hour of CO2 data.
The Genesis block.
Yep, this is it. And so this is live and it's interactive and you can zoom in. This is built on Dash, which is like a web framework for creating data visualizations that's made by Plotly. So it's like a Python-based web platform. That's another repo in the thing. And like, this is an area where we could use a lot of help because this website, I'm not a very good web developer, but like this could use some love. So if you're a web developer out there and wants to help, great. Like we have a ton of projects and work for you that you could do here.
Very cool. Very cool. Well, Keenan, I don't want to cut you short. Did you have anything else to show us on the demo or should we close this out?
I think that's it. Yeah, I mean, like check out the website, ribbitnetwork.org has kind of links to all this stuff, like the GitHub. We have a developer Discord as well. So if like Discord is your thing, you don't have to use it. Like we're working in GitHub issues, but Discord is also there. So there's a link in the GitHub that you can join. And like, we'd love to have you if you're interested or just want to learn. Like, and I think that's the main lesson is like, just go learn about it. Like go learn, like if you want to get involved in climate change, like whether you're a company or a person, like, we live in the best time to learn about climate change that's ever existed. And so like, there's tons of resources, go learn. Starting your learning journey is the most important part. And like, always reach out if I can help you start your journey. I will do whatever I can. So
I think we're going to take that as your plug, Keenan. That was a great one. So yes, I want to reiterate, go check out ribbitnetwork.org. There's some great ideas coming in here. People are saying, go to the Ribbit Network GitHub repo and add on to these designs. There's people saying it would be cool if you added a bird bath on top, maybe on the bottom, so it does actually the water would sprinkle off. Bird bath on the bottom. There's another person who is saying add bird seed reservoir, and then everyone will want a feeder in their yard that's also contributing to climate change. So go onto the repo, submit your ideas, and if anything, fork it and add some really cool designs there and contribute it back in. So it's really cool.
Of course. Thanks. Yeah. Thanks so much, everyone, for the awesome ideas. I'm glad that you're excited about it. I'm super excited about this project. I think it's really important, and I think it will really change the world. And I'm so happy to talk to you about it.
Yeah, no, thank you. And Keenan, I really want to thank you for your time. I know it's valuable. So thank you for spending this hour here with us on Innovation Coffee. Any last things you want to say before we close this out?
No, thanks so much for everybody listening to me. Thanks to you, Robert, and the rest of the team at ARM for hosting me here and like having this great live stream. This is super fun. So cheers.
Thank you. Keenan Johnson, ARM Innovator and Entrepreneur here telling us about Ribbit Network, ribbitnetwork.org. So don't forget to go check that out. Thank you so much, Keenan. And thank you everyone watching. I want to remind you all that if you enjoyed this video today, don't forget to like it, hit that little thumbs up button at the bottom. Head on over to the ARM Software Developer YouTube channel. That's where we're broadcasting from right now. Subscribe to our channel. We go live every single Thursday, every week, right here with Innovation Coffee at 5 p.m. UTC. We'd love to have you here next week. We have guests like Keenan every week. So please join us. Thank you all. Thank you to Rachel behind the scenes who's executing on all these cool links and camera movements and screen shares. That's all her. Rachel, thank you. We're going to close this out. Y'all have a wonderful day, wonderful weekend, and we'll see you next week on ARM's Innovation Coffee. Bye, Keenan. Thank you.
Bye. See you later, all.